This is the 9 meters diameter cutting head with 58 roller cutters of a tunnel boring machine, or TBM for short. This animated sequence shows how the so-called gripper functions. The automated gripper presses against the rock at the sides. The rotating cutting head is pressed against the tunnel face with a force of 26 tons. And under that pressure, each roller cutter chips the solid rock away. The broken rock falls onto a bucket wheel and is then transferred onto a conveyor belt behind the cutting head. While boring goes on, securing work is carried out under the protective roof immediately behind the cutting head. Here, for example, 2 anchor drills with independently maneuverable drilling carriages are being used. They are drilling holes into a rock for anchors, which can be up to 4 meters long. Another example is a mesh placing machine. This travels over the anchor drill and places steel mesh behind the protective roof to give protection against falling rock. Which securing measures are most effective against rock falls depends on the local geology. In one place, steel anchors are best, whereas in another it may be steel mesh, caps or arches. Another means of securing are steel arch segments. The same mesh placing machine pre-assembles them under the protective roof. The complete ring is then transported to its final position, pressed against the rock, and installed there. It would now also be possible to secure with concrete, but we'll come back to that later. When the TBM is working in hard rock, it uses a so-called gripper to press against the rock on both sides. Each stroke of the gripper takes the drive forward another 2 meters. The backup train moves forward with the boring machine. At the end of the stroke, the gripper is retracted, moved forward to the new position, and then tensioned again. The TBM can now cut another 2 meters. Here we see, speeded up, how the feet are raised and lowered. When the second and fourth foot are raised, the backup train moves forward. When the first and third foot are raised, the cutting head drives forward. Here we see the view from above. The hydraulic mechanism releases the gripper for it to move forward. Then it is tensioned again for further boring. The TBM can drive up to 40 meters per day. Hydraulic cylinders control the horizontal and vertical position of the cutting head. This makes it possible for the TBM driver to steer the direction at all times. The shotcrete robot now finally secures the finished tunnel walls. From the boring head to here is a distance of 60 meters. The backup train consists of all the installations and materials needed to supply the boring machine and remove the excavated rock. It is like a moving factory, 410 meters long, which is about as long as 4 football pitches joined end to end. This TBM was specially developed for the hard rock of the Gotthard. 50 of the 57 kilometers of both tunnels will be excavated with tunnel boring machines.